Hi. Hi. So the next topic that needs to be addressed while trying to understand variables and overflow and underflow in handling the data type conversions or calculations over the data types. Casting is an important topic that needs to be understood. So casting itself isn't a necessary solution to overflow or underflow issues, but it's a tool you can use to manage how you handle data types and conversion. So there is implicit casting and there is explicit casting. So when what is implicit casting is, it is basically trying to make something from small to slightly bigger or larger. So basically it is going to go like a widening. And you have one more type of casting called explicit casting. Explicit casting in the sense, when you will try to manually try to convert a larger data type to a smaller type, this will lead to loss of data. For example, I have a simple example given here. So I have an integer which is of type 100 and which is having a value 100. My int is type int and it is taking value 100, and I have my long which is type long and it is taking the my int. So I'm trying to convert my 100 to a my long. If we would have seen in the variable declaration itself, a long should always have a L at the end, like long literal L should come, else it is not going to be considered as long. So when you do this thing, but now that I have 100 is a small value, it can accommodate, definitely 100 can be accommodated in the long type. Whereas if the reverse of this is going to happen, it is going to give you a loss of data, which is going to be your narrowing. But in this case, I am trying to broaden the size of my data. This is going to work, and it is called as implicit cast because this casting is automatically carried by your compiler itself with the line of code that you have written. The long is automatically taking this 100 and trying to accommodate it in the integer into its long length. Whereas here, if you see this example, I have a long type which is of this number. I'm trying to put this number into this, since it has L literal and it is a long number. I'm trying to add that into the integer. I'm trying to do casting also, but the chances here is I'm going to lose the value of the number that I'm actually trying to cast. Let's see the example as well. So So this example, what we have here is I have a number byte, which is of byte type, and it is having 127. And I am trying to cast this number to a short type. And since this is a number is of 1 byte and short is of 2 bytes, this is going to accommodate this. And this is called implicit, which is called implicitly it is going to make handle the conversion. The compiler is going to handle this conversion because it is widening. In case if I'm going to do the reversal of, say for example, I have and this is here, if you see the second example, even this is going to be the implicit casting because it is byte here and I'm converting it into integer. So here I can add my casting. When you do run these things, there's not going to be loss of data. So I'm having minus 128 and I'm adding minus 2. It is becoming 138 here. And here, if you look, it is 127 and I'm trying to add plus 2. And I'm not losing, I use short here and not losing any data because it is properly doing the calculation. But let's say I have a total marks of 20,000 and I'm trying to convert it into byte. Byte and marks is equals to, let's convert typecast to byte and total marks. Okay, and let's try to print this. And I'm trying to use marks. When I try to print this, so here what I'm performing is, this is going to be my narrowing cast, which is my explicit. I'm explicitly trying to fit my 4 byte size integer into my 1 byte size integer, and by doing that, compiler cannot handle this, and even when it handles, it is actually cutting down the so much of my marks. From 20,000 it has become 32. One of the reason to have this much depth of understanding in the casting is there could be times where we might a tester might encounter these kind of errors when they are trying to do calculations in, let's say, when they're trying to actually validate some big data kind of testing or things like that. People might encounter, you might see that maybe in your source system it was 2000 and maybe, but for some point, at some point of time, you're seeing that in your screen it is 32. During the source to target conversion, if the systems are, conversions happening from legacy systems to some higher end system, these kind of data loss might happen. So this kind of knowledge is important while somebody is doing testing. So I hope it helps. Yeah, thank you.